Think of the local storage object. Your browser is a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects, and methods like setItem and removeItem. So in object-oriented programming, we group related variables and functions that operate on them into objects, and this is what we call encapsulation. Let me show you an example of this in action. So here we have three variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee referred to this kind of implementation. So we have variables on one side and functions on the other side. They're decoupled. Now let's take a look at the object-oriented way to solve this problem. We can have an employee object with three properties: base salary, overtime, and rate, and a method called getWage. And why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in the procedural example, our getWage function has three parameters. The reason this implementation we don't have any parameter is because all these parameters are actually modeled as properties of this object. All these properties in getWage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. So that is encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic brought on the inside and a few buttons on the outside that you interact with to simply press the play button, and you don't care what happens on the inside. All the complexity is hidden from you. This is abstraction. In practice, we can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits. First is that it will make the interface of those objects simpler. Easy understanding an object with fewer properties and methods is easier than an object with several properties and methods. The second benefit is that it helps us reduce the impact of change. Let's imagine that tomorrow we change this inner or private methods. None of these changes will lead to the outside, because we don't have any code that touches these methods outside of their containing object. Let me delete a method or change its parameters, but none of these changes will impact the rest of the application code. So, with abstraction, you reduce the impact of change. Now, the third core concept in object-oriented programming is inheritance. Inheritance is a mechanism that allows you to eliminate redundancy. Here's an example. Think of HTML elements like text boxes, drop-down list, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of redefining all these properties and methods for every type of HTML element, we can define them once in a generic object called an HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundancy. And finally, polymorphism. Poly means many, morph means form. So polymorphism means so many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long, even else, or switch and case statements. So back to our HTML elements example. All these objects should have the ability to be rendered on the page, but the way each element is rendered is different from the others. If you want to render multiple HTML elements in a procedural way, our code would probably look like this. When an object-oriented can implement a render method in each of these objects, and render method will behave differently depending on the type of the object you're referring. So we can get rid of these nasty code and use one line of code like this. So using encapsulation, group related variables and functions together, and this way we can reduce complexity. Now we can reuse this object in different parts of program or in different programs. The abstraction will hide the details of the complexity. I'm sure only the essential. This technique reduces complexity and also isolates the impacts of changes in the code. And with inheritance, we can eliminate redundant code. With polymorphism, we can refactor ugly switch case there.